In this presentation, our group is going to talk about ANOVA test versus chi-square test. First, we're going to talk about the definitions, the differences, when do we use each test, distributions, data constructions, and we're going to demonstrate each test in SAS. For the definitions, ANOVA test is also known as the analysis of variance test, is a statistical procedure used to test the degree to which two or more groups differ in an experiment. And it has three types of tests. One-way ANOVA is used between groups, two-way ANOVA without replication, and two-way ANOVA with replication. And the chi-square test. This test is used to compare more than two variables for a randomly selected data, and it is used to describe the magnitude between the observed data and the data expected with a specific hypothesis. But what are the underlying distributions that are used in each test? We use the F distribution in the one-way ANOVA, and in the two-way ANOVA we use the normal distribution. But for the chi-square test, we use the chi-squared distribution. What is the difference between each test? For the ANOVA test, in ANOVA we have two or more group averages that we want to compare. In this test, one variable must be categorical and the other must be continuous. For example, we want to examine if the intake of sugar, which goes from 0 to 20 times, differs by grade level. In the chi-square test, is used when we have two categorical variables, like gender or alive and dead, and we want to determine if one variable is related to another.
Hello, I'm Joey, and I'm here to talk about the different types of ANOVA tests. So the first ANOVA test is a one-way ANOVA, and it compares groups of categorical data of a single factor to a single continuous response variable. So this uses the F distribution, as Dina mentioned before. So an example of this would be, as she said, comparing grade level, which is a categorical data set, to sugar intake, which is continuous. The second type of test is the ANOVA 2 test, or two-way ANOVA, and this compares categorical groups of two or more factors for mean differences based on still a single continuous response variable. It uses the normal distribution. An example of this would be grade level, which is categorical, and gender, which is categorical, to sugar intake, which is continuous. Lastly is the M-ANOVA, or multivariate analysis of variance, and this compares one or more, can be one-way or two-way, groups of categorical data to multiple continuous response variables. That uses the multivariate F distribution, so a little bit different than the other F distribution, which is Wilks's lambda distribution. An example of this would be grade level categorical and gender categorical to sugar intake continuous and height in inches continuous.
My name is Joo Kim, and I'll be demonstrating the examples of chi-square test and the ANOVA test. So first, I'll be doing the chi-square test first. So we're using two categorical data, which is city and model, like this, and I click OK. So I see this mosaic plot, and if I go down, I see the probability of I see the result of chi-square test, and if I look at the likelihood ratio, I see 0.48, which is 48%, which is near 50%. So I would say they are somewhat correlated. They're not very high, but we cannot say that they are not really correlated. And second part will be the ANOVA test, which is comparison, which uses a categorical data and the continuous data. So for this, we're gonna use miles and models. So here's my data. Here's my plots. If I do means in ANOVA, so I get 0.09, which is roughly 10%. It is higher than 5%, but still it's kind of very low to say that they it's showing any correlation. So I'll say it's not very correlated.